In our previous lesson, we talked about elements as well as isotopes. So today we're going to be talking about ions. Remember, when we were talking about isotopes, we said that we were changing the number of neutrons, but again, we can never change the number of protons for a given element. Now, we're going to be looking at something different. If we are changing the number of electrons of an atom, then we are going to be forming an ion. So let's start with the definition of an ion. An ion is going to be an atom or molecule with a net electric charge due to the loss or gain of one or more electrons. What do I mean when I say net electric charge? So previously we said that a neutral element has the same number of protons as well as electrons, and that's because protons are positively charged and electrons are negatively charged. So if they were equal in number, then we would get a neutral molecule. However, if I change the number of electrons we have and it is no longer equal to our number of protons, then we are going to get a net charge. There are two different types of ions depending on whether we are gaining or losing electrons. So the first type of ion that we are going to be talking about is called a cation. And cations form due to the loss of an electron. Now this might be a little bit confusing, but if we are losing a subatomic particle that is very negative, that means we are going to end up with a net positive charge because we're losing negativity. So I know it seems a little bit backwards, but cations are going to end up having a net positive charge. And a way I remember this is through the phrase, cats have paws, so cations are positively charged. On the other hand, if we are forming an ion due to the gaining of electrons, that means we are adding more negative particles, so then your overall net charge is going to be more negative than positive. So any of those ions are going to be known as anions. Let's take a look at an example. So the first example we are going to be looking at is lithium ion. Before I get started, I want to locate lithium on the periodic table. And lithium's symbol is going to be Li. So I see that lithium has an atomic number of 3. Now what does that mean? That means that lithium has both 3 protons and 3 electrons if it is neutral. I just want to remind you, our first energy level around the nucleus can only hold a maximum of 2 electrons. So if we have an element with more than 2 electrons, then we need to start filling up energy levels that are higher than that first energy level. And all of those higher ones, so from the second energy level on, second, third, fourth, etc., those can hold a maximum of 8 electrons. And we actually have a rule called the octet rule, and this is basically the stability of elements depend on if they have a full set of valence electrons. So that means, does the first energy level have a full 2 electrons? Do the second, third, fourth, fifth have a full 8 electrons? And if not, then an element is going to try to gain or lose electrons in the formation of an ion in order to get that ideal stable state. Okay, so back to lithium then. Since lithium has 3 electrons, then we would expect to see 2 electrons in that first energy level. And then in the neutral state, we would see 1 valence electron in the second energy level. Now, there are 2 options that we could do. We could either fill our second energy level with 7 more electrons so that we could get our octet, or we could lose 1 electron and so that we could have a full first energy level. Again, our first energy level can only hold 2. Between those 2 options, it would be easier to just lose 1 electron rather than trying to gain 7. So if I lose 1 electron, that is going to adjust my charge. So my protons are going to stay the same. We're going to have 3 protons, but we're losing 1 electron, so now we only have 2 electrons. Remember, protons are positively charged, so positive 3 minus 2, and those are going to be because electrons are negative, gives us a net charge of positive 1. So now that we have changed the structure and the charge of lithium, we do need to indicate that we've made a change on our atomic structure diagram. So what you're going to do is you're just going to draw brackets around your whole atomic structure, and you're going to put its net charge in the top right-hand corner, kind of like where an exponent would sit. So I'm just going to put brackets and then put a +1 here. Now, if we have an ion that has a net positive charge, remember this is going to be called a cation. Cats have paws, and cations are positively charged. Let's take a look at one more example. So here I have oxide ion. If I locate oxygen on the periodic table, you would see that it has an atomic number of 8. That means at the neutral state, oxygen has both 8 protons as well as 8 electrons. So let's start with drawing the original atomic structure of oxygen. We would expect to see 2 electrons filled in our first energy level, and that leaves us with the remaining 6 electrons. That means we're going to have 6 electrons in our second energy level. Remember, the outermost electrons are called our valence electrons, so I could also just say oxygen has 6 valence electrons. That means that it does not satisfy our octet rule. So again, we have 2 options. We can either gain 2 more electrons so that we have 8 valence electrons, or I could lose those 6 valence electrons, but it would just be easier to add 2, right? So if I'm going to add 2 electrons, so I'm going to draw those in. That means we're changing the number of electrons and we are going to have an overall net charge. Our number of protons stay the same. We still have 8, but now we have 10 electrons. So we have more negatively charged particles. And if you just do basic math, then you would see we have a net charge of -2. Again, I'm going to draw brackets around my atomic structure, and I'm going to write -2 in that exponent spot so I know that I've made an adjustment onto its structure. So oxide ion, which is O2-, is now stable. So go ahead and try these 2 examples. You may want to pause the video, but can you identify protons, electrons, and neutrons in our neutral phosphorus? And then can you identify those same categories, but for a phosphide ion? We can see that phosphorus has 15 protons and 15 electrons in the neutral state. In order to get the number of neutrons, remember you're just going to be looking back at the atomic mass, which we can round to 31. And atomic mass is going to be equal to the sum of the protons plus our neutrons. Well, we know our number of protons is 15, so if we do 31 minus 15, then we get 16. So phosphorus has 16 neutrons. Phosphide ion has a charge of 3-, which means that we are going to be gaining more negative particles. We are gaining 3 more electrons. So our protons and neutrons should stay the same. We still have 15 protons and 16 neutrons, but our electrons are going to be 3 more than we had in the neutral state. So we originally had 15 electrons. Now phosphide ion would have 18 electrons. Can you do the same for hydrogen and hydrogen ion? So hydrogen in the neutral state has an atomic number of 1, and then this means that it has 1 proton as well as 1 electron. This might look a little bit tricky, but it's still the same concept. Our atomic mass we would round to 1, so atomic mass is going to be protons plus neutrons. So we said our number of protons was 1. 1 plus what equals to 1, and that just means that our number of neutrons has to be 0, which is possible. Now, over on our hydrogen ion, we see that it has a charge of H plus 1. If there is no number there, then we apply that it is just a 1. So that means that I'm going to be losing 1 electron. Our protons and our neutrons should stay the same, so I should still have 1 proton and 0 neutrons, but now I'm going to be losing the only 1 electron I have, so that is also going to be 0. So 1 proton, 0 electrons, and 0 neutrons for hydrogen ion. Thank you guys. I'll see you guys next time. Bye.